video is going to discuss how to graph some trigonometric functions. First of all, let's discuss period. The period is the time it takes to complete one cycle. Okay, so let's just go over here and give you an example of a sine graph. Think back to those spaghetti sine curves that you did. There are 4 sections. We're going to start in the center on the origin, and the curve goes up to a maximum, then it comes down and touches 0, then it goes down again to a minimum, and it comes up to 0. And that is one complete cycle. That is one period of sine. After this point, it would start to repeat. Amplitude is how high / low, how high or low the graph can reach. So we're talking about sine and cosine here. They have amplitudes. A normal sine graph, like the spaghetti ones, reached up to a point of 1 and as low as -1. And unless we're stretching them out, that's how they are, the basic ones, that is. Now let's talk about cosine, because cosine starts a little differently. He doesn't start at a middle. He starts up at a maximum point, up at a high, then he goes down to a middle, down to a low, he goes down, down, up, up. And that is one complete cycle of cosine. Now he's going to keep repeating, so he has the same shape as sine, except he starts high, so it's shifted over a little bit. Okay, so sine and cosine are very much related. If we take a look at some basic equations here, y equals a times the sine of bx, and even y equals a times the cosine of bx. Okay, both of these have the variables in the same place. The amplitude formula is absolute value of a, and that a number is the number out in front. If you don't see a number like these guys, it would just be 1. So it reaches up to 1, down to 1. Period, the formula for period is 2 pi divided by absolute value of b. So that b value right there out in front of the x is what affects the period. This is something very important here. Each section here, the way that you find it is you divide the period into 4 sections. Do you know why there's 4 sections? They come from the 4 quadrants. So up, down, down, up. That comes from quadrant 1, 2, 3, and 4. And if we keep going around the circle some more, we'd get another 1, 2, 3, 4. So dividing into 4 is very important. Okay, let's go ahead and start our first graph. So here's our equation. There's a couple of things you have to figure out first, and then we'll put that all on the graph paper. So first of all, the number out in front here is a 1. So that is the a value. The b value is a 2. And so we're going to answer some things. First of all, since sine, the formula is 2 pi divided by absolute value of b, which is a 2. So the period is pi. Okay? And underneath period, I want you to write down what a section is. In order to get the graph correct, you need to know a section. So we're going to take pi, and it says that we have to divide it by 4. Okay? So what does that mean? Let's go on over here to the axes. So you got an x-axis, nice long one, and there's a y-axis. And so what you need to do on the x-axis is put the sections. So we've got 1 out of 4. Try to make sure these come out very even. Use a little finger if you can to make sure the spacing is nice. 1 can't be tiny and 1 can't be huge. They're 4 equal sections. 1 out of 4 plus another 1 out of 4 takes us to 2 out of 4, but we'll write pi over 2. Another one takes us to 3 pi out of 4, and 4 out of 4 brings us to pi. How do I know that's right? Was I supposed to finish at pi? Exactly, the period is pi. After 1, 2, 3, 4 sections, the period should be finished. Now we're going to also go to the left here. So we're just going to copy these values. Maybe what you should do first is try to make 4 equal increments, and these values are all negative. Okay, and then negative pi. So our x-axis is nicely spaced. We figured out the values. Now it's time to talk about the y-axis. And the way that we're going to do that is by examining the amplitude. The amplitude is absolute value of a, which is a 1. So on this graph, my sine curve is going to reach up as high as 1. That's 1 up. Then it's going to reach a value of negative 1 down. Okay? What helps me be a better grapher and have things come out a little neat is I put these dashed lines here. Now these are not asymptotes. This is just going to help me be a nice even drawer. So I have to reach up to 1, down to negative 1, not too low, not too high. That helps me a little bit. Okay, and it's time to start. Now this is a sine graph, so I think back to the spaghetti sine curves that you made. Sine started at the origin. At the next special section, sine needs to be up at a maximum. So I'm going to put a point right there. I'm going to aim for that point. The curve goes up, up, up. And by the next special section, by pi over 2, the graph is going to be at a 0. Curvy, curvy down. Okay, make sure you put a point on that value. At the next section, 3 pi over 4, you're going to be at a minimum. And then at pi, you're going to finish and be back at a 0. Some people turn their paper upside down because they draw their up humps a little better. If you can, be nice and smooth and curvy about this. Okay, I have to put a little note down here. Do not draw your curves like mountains. Okay, they're not pointy. They have to be smooth and curvy. Let's go to the left here. So this is 1 period. This is 1 period. I'm also going to draw another period here to the left. Okay? This is 1 period to the left. I am always going to require that you draw 2 periods. One to the right, one to the left just seems to make sense. It fits on there nicely. The next special section is a minimum, then a 0, then a maximum, then a 0. So we've got curvy, curvy. Make sure you hit those points. The sine graph reaches as low as negative 1 and then comes back up to 0. That's 2 periods of sine graph. Let's answer some questions about it. The domain, when does this curve stop? It never stops. It's smooth and continuous. The domain is all reals. All sine graphs have domain all reals. The range, look at the y-axis. How low does it reach? Not negative infinity, negative 1. Does it touch? Yes, so let's bracket it up from negative 1 to positive 1. Okay. Decide of any asymptotes? No. I'm just going to say none, okay, or dash it out. Sine does not have asymptotes. Some of the other curves do. Now the zeros is where it's going to get more fun because he touches the x-axis. There's a 0. There's a 0. Is it just those many? No, there's infinitely many. If you started to make a list, you'd be there literally forever. So what we're going to do is we're going to write an equation for the zeros. X equals, where's the first one? The first positive one is at 0. So you start 0, you look to the right, 0. Now there's lots more. So I'm going to write an equation saying plus or minus. Plus or minus, yeah, because if you go to the right, or you go to the left, there's another one. Now, how far to the right? That's pi over 2. But what if we go pi over 2 to the left? Is that a 0? Absolutely. Plus or minus pi over 2. But wait a minute, what if I go another pi over 2? There'd be a 0. What if I go another pi over 2? There'd be a 0. So what you do is you say n, and n stands for natural number. So go plus or minus pi over 2, 1 time, 2 times, 3 times, infinitely many of times. So the rule here is, okay, you always state the first one, and then this is the space to the next one. The space to the next one. And the sooner you get the hang of that, the easier everything's going to be for the rest of this chapter, because that technique is how we state asymptotes and zeros for for all the graphs. Find the first one, either 0 or positive, and then what's the space to all the next ones? Okay, that is a sine graph. Now let's go talk about his pal, the reciprocal cosecant. Okay, looking at that one, it's going to be very, very similar to sine. So what we're going to do here is write y equals 4 times the sine of 3x. So this sine graph is related to that cosecant graph. Okay? So whatever his period is, his is. Whatever his amplitude is, it's going to be related. So the period is the b value. The b value. So we've got 2 pi over 3. Okay. Now it's time to find a section. Okay. We have to divide by 4. Divide by 4. What helps some people is take this fraction. Let's go crawl in the corner over here. 2 pi over 3 has to get divided by 4. Maybe an easy way to think about this is to say 2 pi over 3, divide terms into times 1/4. And then we'll cancel, do some work right there, and we get pi over 6. That's a section. Okay, so let's go draw our axes. The x-axis needs to get sections of 1 pi over 6. 1, 2, 3, 4. Nice and even spaces. Maybe the size of a pinky finger every time. 1 pi out of 6. 2 pi out of 6. 3 pi out of 6. 4 pi out of 6. I hope that you wrote down the reduced ones and not what I was saying. Let's go ahead and copy these over here. Negative pi over 6, negative pi over 3, negative pi over 2, negative 2 pi out of 3. How do I know if that worked out right? Was I supposed to finish at 2 pi out of 3? Well, yes, the period was 2 pi out of 3. That's the perfect way to finish. That's the period for these graphs. Okay, amplitude. The amplitude is the a value, so we're going to say 4. Okay, and the rest of the questions I'm going to answer once I see the graph. So what we're going to do here, let's put the 4s on. Okay, for people that are really big writers, make sure there's enough space above and below. Don't take up this much space because we're actually going to draw above and below that. So what I want to see is a sine graph. But that's not the official graph. I want to see a dotted sine graph that's going to help me draw the cosecant. Okay, so this one right here has to be dotted. Has to be dotted. Sine starts at 0, and he goes up to a maximum, then down to a 0, down to a minimum, up to a 0. The reason I'm doing this dotted is that's not the cosecant graph. This is sine, but it's going to help me graph the cosecant graph. Okay, here's the dotted sine graph. Okay, now we're getting there. So I know that cosecant is 1 over sine. Hey, what happens if sine was 0? Would cosecant like that? No, he'd be undefined. This sine curve is touching 0 right there. And he's touching 0 right there. What happens when the sine equals 0? Cosecant would be undefined. Undefined. So at that value, you need to draw a vertical asymptote. So cosecant has asymptotes wherever sine touches 0. Wherever it touches 0, you need to draw an asymptote. There's no graph there. He'd have a problem. Okay, everything now should be dotted. We haven't even drawn the cosecant graph yet, but we're ready. So go ahead and get out your fancy color now. Okay, at the top of this sine graph, we're going to go ahead and put a point. Touching, they're going to connect. The cosecant curve starts right there at the maximum, and he kind of looks like a parabola. Approaching that asymptote, but not touching. Down here, there's a minimum, so put a point, and draw a parabola going down. Approach those asymptotes. If you drew really wide ones, then you got to make your graph look really wide. Get closer and closer and closer to the vertical asymptote. This is one period, one up and one down branch. This is one sine graph. This is one period of cosecant. Let's go over here and draw the other two parabolas. Because to graph 2 periods worth, you have to make sure that you have 4 parabolas. So I'm noticing here that this graph does not have domain of all reals. There are breaks in the graph. There's cosecant, then it stops. There's cosecant, then it stops. So it's all reals except x cannot equal. Where's the first break, the first asymptote? Is there one on 0? Yes, so 0 is the first one. And then there's asymptotes everywhere, plus and minus. How far to the right or how far to the left to the next one? Plus or minus, what's the distance to that one? Pi over 3n. Don't forget the n. Okay, good. The range of the y values. Range of the y values. So this graph goes down, down, down forever, but there's no graph there in the middle. So first we'll start with negative infinity all the way until what point? It touches right there. It touches that sine graph. So negative 4 is going to get brackets. Okay, oh, is there more graph? Absolutely. Starting at union. Brackets 4 all the way to infinity. Are there asymptotes? Yeah, we kind of already talked about the asymptotes. So if you did domain, you're kind of already ready for some asymptotes. X equals. This is where they are. The first asymptote is on 0, plus or minus pi over 3n. Does this cosecant graph touch the x-axis anywhere? It does not, so we're just going to go ahead and say none. If the cosecant graph got shifted up a little, then he might touch the x-axis, and then we would have some zeros. Okay, but we're not going to shift anywhere soon. All right, let's talk about a cosine graph. Cosine, we've got an a value and we've got a b value, so let's do the period first. The period is 2 pi over b, which is a 2, so the period is pi. Let's go ahead and officially write down what a section is. To find the section for sine and cosine, we have to divide the period by 4. And the amplitude for this guy would be 5. Okay. Let's go ahead and get our x-axis and our y-axis ready. If you found your section, you're ready for your x-axis. Pi out of 4. Here we go. 1 out of 4. 2 out of 4. 3 out of 4. And 4 out of 4. Did that work out right? Well, looks good for the period. Negative 1 out of 4. Negative pi over 2. Negative 3 pi over 4, and negative pi. The amplitude is 5. Okay, don't feel like you necessarily have to go way up high. Just find a value that looks like 5. 5 up, 5 down. Try to be equidistant here. I'm going to put some dotted lines so I draw as straight as I can. And I think it's time to draw a cosine curve. You have to remember cosine. Does he start at a middle? Or a high or a low? Cosine's going to start at a high, at a maximum. At the next special section, he'll be at a middle. Then he's at a low. Then a middle. Then a high. High, middle, low, middle, high. And make sure when you draw him that he's smooth and curvy. Try to get to those points. There's a point. There's a point. There's a point. There's a point. Going to the left, he'd have a minimum, a 0, a maximum. There is the cosine curve. Some people tell me they don't like leaving cosine hanging like this. If 2 periods worth is not good for you, you want to add another one. If you want to add 5 pi out of 4, go ahead. You can do extra. And if you want to bring them down to the x-axis because you like the way that looks, you can do extra if you like. Okay, but you have to do at least that many. Domain. Domain is all reals for cosine. He does not stop. The range goes from brackets as small as -5 up to +5. Okay, no asymptotes for a cosine curve. Does he touch the x-axis? He does. I'm going to switch pens here because this one is a little more exciting. X equals, where's the first one? It's not 0. The origin is not an x-intercept. The first one is pi/4. Okay, that was different, being a little bit over. Now, let's look very carefully because the space to the next one is 2 sections. The space going left is also 2 sections. This space is not 3pi/4. The distance from here to here is 2 sections worth. And the easiest way I found to figure out what this is just to slide my fingers over and say, hey, what is 2 sections worth? And that answer is pi/2n. Okay, from 1/4 to 3/4 is a distance of 2 pi/4, or 1/2 pi. Okay, let's continue on to our last example. This is a secant curve, so we're going to have to draw his friend, a cosine graph. 3/2 x. Okay, everything about a cosine curve is going to be the same for the secant curve. We'll do lots of dashes, and then we're going to go ahead and add that on. Okay, so first of all, what's the period? The period is 2 pi divided by b. Ooh, the b is a fraction, 3/2. It might be easier for us to think of this as 2 pi divided by 3/2. Maybe we should think of that as 2 pi times 2/3. 2 pi times 2/3. So survey says 4 pi/3. Let's go ahead and put that in a box. Okay, I got so much work there. If you got a lot of work, go ahead and box your answer. Okay, and now it's time for a section. Now it's time for a section. If you need to crawl in the corner, do some more work, please take this and divide by 4. Dividing by 4 would put a 4 in the denominator, which would make those 4's cancel. So I'm coming up with pi/3. And amplitude? Amplitude is absolute value, so that would be 1/4. Okay, once you get your period, your sections, and your amplitude, you're ready to label your axes. So we've got our x-axis and a y-axis. Our sections are 1/3, 2/3, 3/3, and 4/3. Did it work? It certainly did. -1/3, -2/3, -pi, -4 pi/3. Okay, and the other thing is going to be amplitude. And again, I don't necessarily make it be really, really tiny just because it's 1/4. I'll just label it 1/4 and make it be a good amount. Okay, now everything needs to be dotted. We're not ready for secant until you draw me a nice cosine. So let's talk about cosine. Does he start high, middle, or low? He usually starts up at a maximum, but what does this negative want us to do? Reflect over the x-axis. So instead of starting at a maximum, he's going to start at a minimum. So the cosine curve is going to look like this. Okay, there's the dashed cosine curve. Now it's time to go ahead and get the asymptotes in. Whenever cosine touches 0, which is right there, secant is going to have an asymptote. If he touches 0 there, that's where you draw the asymptote, wherever they're in the middle. That would make secant undefined. Okay, everything's dashed. Now it's time to pick up your fancy color. Now we will draw the cosine, or the secant curve. So at the top of a hump, go ahead and draw a parabola opening up. Make sure you get close to the asymptotes. How many periods have I drawn so far? That's one complete period. But I'm requiring you to draw 2 periods. So let's keep going. Here's another branch. But that's not enough. I need to see 4 parabolas. Well, here's a minimum. So there's half of a parabola here. And there's half of a parabola here. Some people don't like drawing halves. They want to draw extra and complete the parabola. Fine by me. Okay, let's answer some questions. The domain is all reals except x cannot equal. Where's the first place there's a break in the graph? There's touching 0. The first break in the graph is at pi over 3. Pi over 3, plus or minus. The space to the next asymptote, the next break, the space is 2 sections worth. And how much is 2 sections? 2 pi over 3. 2 pi over 3n. Does anybody realize that 2 sections is exactly half of the period? Since 2 sections is half of 4 sections? Okay, how about the range? From parentheses, negative infinity all the way up to negative 1/4 with brackets, union 1/4 up to infinity. Are there asymptotes? Well, yeah, we kind of just talked about them. X equals this time. The first one's at pi over 3, plus or minus 2 pi over 3n. And does this blue secant graph touch the x-axis? No, it does not. So make sure you answer none or say none. Okay? All right. Great job. I'll see you tomorrow.